Sentiment analysis on Twitter tweets, CS3840, Applied Machine Learning, by Pauline Arcita, Stephen Bizimana, and Hazel Gabutan. Motivation. The Sentiment 140 dataset with 1.6 million tweets was swarmed by labeling all tweets with a smiley face as positive and a sad face as negative. In other words, classification via emoticon. We plan on using this dataset to classify tweets based on each word in the tweet. If the model we build can intuitively label tweets as negative or positive, then we can assume that the classification via emoticon works as expected. If the model we build cannot intuitively label tweets as negative or positive, then we can assume that the classification via emoticon does not work as expected. The model that we build that best fits our testing data, which will also come from Sentiment 140, will be the one that we use to test our own generated tweets to see if they are intuitively labeled. Intuitive labeling. We will make our own tweets that we collectively agree are negative or positive. This agreed upon label is the intuitive label. Problem. This is a classification problem. We will attempt to train a model to intuitively classify if a tweet is either positive or negative. Hypothesis. Our hypothesis is if we train a model on the words of a tweet, then the model will be able to intuitively classify the tweet as either positive or negative. Data description. Raw data. The raw tweet data is provided in a CSV file with each row containing data for a different tweet. The first column is the target, which goes from 0 as negative, 2 as neutral, or 4 as positive. As a note, there are no neutral tweets in the dataset. The second column is tweet ID, third column is data creation, fourth is flag, fifth is user, and sixth is text. Data pre-processing. First, we'll remove all columns except for target and test. Change all positive tweet labels from 4 to 1, so negative is equal to 0 and positive is equal to 1. We'll remove any user mentions in the text, for instance, mentioning someone in the tweet, and then change all letters to lowercase. Here are examples of raw data from the dataset, and below are those same examples but pre-processed.
Algorithms. We use 6 logistic regression models and 2 neural networks. As seen is the performance metrics for each of the models. Highlighted is our best model out of all of it. As seen from the statistics from all our models, the 5th logistic regression model is the one we chose as the best model out of all the other models that we have. The 5th and 6th logistic regression model has an F1 score of 0.803 and a precision score of 0.791. But since the 5th model has a recall score of 0.816, we chose this model as the best one. We generated our own 150 tweets consisting of an equal number of positives and negatives. The 5th logistic regression model is tested on these tweets to prove if they are intuitively labeled. The performance metrics is as shown below. We can see that the F1 score at 0.911 and recall at 0.960 for our logistic regression model that is tested on the intuitive tweets that we created is approximately equal to 1. Having 64 true negatives, 72 true positives, 3 false negatives, and 11 false positives, we can say that this is a good model because true negatives and true positives are still greater than our false negatives and false positives. Broader application area. Our hypothesis is that if we train a model on the words of a tweet, then the model will be able to intuitively classify the tweet as either positive or negative. In our opinion, our evaluation is sufficient. We are satisfied with the results that we got because when we trained our model using 1.6 million tweets dataset, we got good scores where recall is 0.816, precision is 0.791, and F1 score is 0.803, which are pretty high scores. With the tweets that we made up, our recall is 0.960, precision is 0.867, and F1 score is 0.911, which are better results. We can say that our model can classify a tweet whether it is positive or negative. We can also assume that the classification via emoticon from the original dataset works as expected.
For the challenges as a group, one of the challenges that we encounter is not being able to meet and work on the project face to face due to the pandemic. However, we managed to meet up once a week to work on our project through Discord. We got individual challenges for Steven.
Since one hot encoding was used on every word in the 1.6 million tweet dataset, our input size was very large, which caused models like neural networks, decision trees, and SVMs to take very long to train. The neural network models we included took about 11 hours each to train. The challenge I faced was finding a balance between model diversity and training time.
For Hazel,
The main challenge that I experienced during the process of creating this project is managing and balancing the time between working with this project and working on other projects for my other classes. I overcome this hurdle by making sure that I attend the online meetups with my teammates.
for me, my main challenge with this project is learning a new language, which is Python. I overcame it with the help of my team. They directed me to a website that has a Python course, and after taking that, I understand Python more. For future work, we can use a dataset of movie reviews such as a dataset from IMDb to train and test our model to be able to identify if each of the reviews from the dataset is either a positive or negative review. We can use more models such as decision tree, k-nearest neighbors or KNN, naive Bayes classifier, and support vector machine. We can also add AUC or area under the curve as one of our evaluation metrics. And that concludes our project. Thank you for watching and we hope you have a great day.